So we're doing our reassessment and starting our reassessment for our first quiz, which is quiz 1.2, despite what it may say at the top of the paper here. And it's over our properties of exponents. And the first part of it was adding and subtracting the properties of exponent. And what we have to remember, the most common mistakes with adding and subtracting monomials with exponents is the exponents and the variables don't change. A lot of people, when they did this first problem, they said, oh, well, that's going to be x to the 14th by adding 7 and 7 together. But if I just told you to add 3x plus 2x, it's 5x. You keep the variable to that power. You do your addition and subtraction with the coefficients. So as we're looking at this problem, that's not part of our answer. That's just an example. As we're looking at a problem, as I see an x to the 7th y to the 3rd with an x to the 7th y to the 3rd, the first thing that we have to recognize and make sure of is that the variable and exponents are the same, which they are, have the same variable portion. That's the first part. And we do our math with the beginning of that with the coefficient. So I'm looking at -6 minus 2. And if I have -6 minus 2, whether last year you learned keep, change, or add the opposite, we should see that if I'm at -6 and I go 2 farther deeper into the negative, I'm at -8. And that x to the 7th, y to the 3rd stays the same. When adding and subtracting variables and exponents do not change. It's when you multiply and divide that they change. So our answer to that first one should be -8 x to the 7th y to the 3rd. As I look at the second problem, we can only combine things that have the same base to the same power. So I'm looking at that 7a squared. 17a doesn't have the same exponent, so those don't combine. -3a squared, notice I'm keeping that sign out in front. So for my a squared portion, if I have 7a squared and I subtract 3a squared, I get 4a squared. Notice my exponent and variable doesn't change. And I cannot combine those with things that don't have the same variable to the same power. So I'm separately now looking at this -17a plus 2a. And if I do -17 and increase it by 2, I'm at -15a. Adding and subtracting variables, make sure you have the same base to the same power. That's all you can combine, and you don't change that base in the power. It stays the same. As I'm looking for this, I'm finding this sum. What we hopefully know is the sum is the answer to an addition problem. So I'm saying, this is saying, what's 2mn plus 9mn? Variable's the same, exponent's the same, so I keep my mn and I add my coefficients. If you have any questions, make sure you hunt us down and ask us. Last but not least for that one, we're finding the difference. I'm subtracting 8p squared q to the 4th from -5p squared to the 4th. The fact that I'm subtracting it from that means I reverse the order. So this is saying I have -5p squared q to the 4th, and I'm subtracting 8p squared q to the 4th from that. So if we follow the same steps we did up here, has the same variable to the same power, we keep that p squared q to the 4th power, and we ask ourselves what's -5 minus 8. If I'm at -5 and I subtract 8, I'm at -13. Another way to think about it is if you subtract, you add the opposite, you keep, change, and that's still giving me -5 plus a -8, -13 p squared q to the 4th. You're going to have make sure you input those answers correctly on the problems below. That's the first part, is making sure you watch the video and you understand the concept.